Okay, so on page 33 of your lecture notes, I'm just pointing it to the camera here. Okay, so on page 33 is just a summary of the stuff that I've explained in terms of what are the functionalities. Okay, for example, what is the read-write signal line, what is chip select, and those kind of things. So basically, as I want to summarize this thing, okay, in a memory context, you need three main things. You need to know what is address line, what is data line, and what is a control bus. Data bus, control bus. Okay, so for address bus is unidirectional, remember. Data bus is bidirectional because you can read right. And you have control bus. Control bus refers to things like this. Okay, the read write. Okay, chip select or ME sometimes. Memory enable. So this one and this one is actually the same thing. Okay, chip select and memory enable is the same. Used interchangeably. Okay.
So teacher, the read and write, then all this is all under the control bus.
Yes.
Only for the case 2, the control bus is one of the lines is connected.
Yes, you are doing a memory decoding here. So
but this whole thing is called memory.
Yes, the whole thing is called memory decoding. How do I decode the memory? This is the whole thing. If you just Google, right? You Google memory decoding, you can come up with something. But this whole thing that I've just done, okay, explaining all these things, right? This is memory decoding. Okay, you are using an address line to decode the memory. Which one to use? Is it okay?
Teacher, why got some use memory enable, some never?
It's the same. Some books put.
Some volatile, some not volatile, right?
That's more.
No, what I mean is that these and these are used interchangeably. It's the same function. Chip select is the same as memory.
You want to wake up the chip.
Yes, wake up the chip. Okay, good for remembering that. Okay, waking up the chip. Okay, start looking at the next one. What example 2? Page 34. This one is very important. Page 34. Inside your tutorial question, and then I think exam you sure have this kind of question. They give you a memory map, ask you to tell us the address. Okay. So you have page 34. Okay, on page 34, where example 2, if you look at that question, okay, you are given some memory on a memory map. You have a couple of memories: 4K flash, 1K EEPROM, 2K RAM, 1K ROM. Okay, now you are required to know how to work out the address, the ending address. And for example, what they want you to do is to tell us, for example, part 1, right? Determine the total number of memory location and the number of address lines. Okay. Now, first of all, to answer that question, page 34, okay, you need to work out what is the total capacity of the memory. Okay, so on the first part of the answer, looking at the answer there, okay, you can see that the total memory capacity is 8K. Right? You just sum up the memory. Okay, 8K. Okay, please look. Right? Because I take 4K plus 1K plus 2K plus 1K. Total 8K of memory, right? Now, so for 8K, we can further break it up, right? 8K. What is 8K? Can we break it up further? Can, right? Page 34. Okay, I'm looking at page 34. I'm just going to erase half here. Okay, so in order to do that, okay, 8K, right? 8K memory. So this one is on page 34 of your lecture notes. 8K. No, you know that 8K is equivalent to 8 times 1K, right?
Yes.
What is 1K? I hope you by now know. 1K is 1024, right? But it's also equals to 2 times 2 to the n, right? Which is 10 lines, right? 1024, remember, I hope you remember. 1k is 1024. Okay, which means that this fella here, okay, if I were to represent it equivalent, is actually 2 to the power of 10. Agreed? Yes, 2 to the power of 10. Okay. Now further then, okay, I need to know how many address lines. Remember, I need to find this n, this magic number here, this n. Because this n tells me the number of address lines. Okay, this is a very magical thing you need to know. So I will know that 8, I can further break it up, 2 to the power of 3, right? Okay, so according to your laws of indices,
30.
yep. Okay, 13. So I know physically I need 13 address lines. Okay, that answers the first portion, first part. Is that clear? First one. Now for the rest of the second part, now the second part requires you to know a bit, or I think you all should know your hexadecimal. Denise, why so excited? What are you all watching there? You are watching something. Yeah, 1k. Yeah. Okay, what is 1k? Look at it, 1k is 2 to the power of 10, right? I just explain. I'm looking at page 35 now. Okay, page 35. Can you please refer to page 35 of your lecture notes? Okay, I'm looking at the top part of the solution there. Okay, so what is 1k? 1k means 2 to the power of 10, right? Or it's actually 1024 base 10. Remember, base 10 means decimal. Now, can you convert this into hexadecimal? Hex. Yep.
400.
Yes, correct. So it's actually, because it's 16 address, no, sorry, it is, just now how many lines? 13, right? So I need this.
Actually, what's hexadecimal for?
Hexadecimal means base 16.
Yeah, what is it for?
Huh?
What is it for?
It's used to express the, how to say, it's used to represent memory. Because instead of writing zeros and ones, right, I use hex to express. So that means F, right, represents 1, 1,
1.
yes. You all learn, right, hex,
Yes.
0 to 9, right, then A to F. You know what I mean? So if I say FF means what?
8, 1, 2.
Yeah, correct. But this one is represented in base 2 lah. This FF is base 16.
Oh,
Okay? 16. Of course I can keep going, right? I can do this, then you got a lot of ones. But reality is that people don't like to write this. Engineer like to make things simple. Instead of writing 1 million ohms, okay, I write 1 meg. Okay, I don't like to write this, right? If I want 1 meg ohm, I'm not going to write for you 6 zeros. I'm going to just write this. Same thing. Instead of writing this, I'm going to write in express in hexadecimal. Fair? Fair? This one very. Okay, so this one you can express in hex. Okay, so hex. 4 line, 4 line, 4 line.
4 line.
Because 1 is 4. Just like F is right. So isn't this 4 address line? So 4, 4, 4. Okay. So you know it's this.
So you don't get it. Why is 0 equal to 4 lines?
No, because of course, but usually, of course, you can put like that, right? No? You can do like that, of course.
What number like so long?
Usually they express in 4 digits. Okay. Yeah, that's fine. But your calculator will give you this. Okay. Yeah, okay. Now, so look at the next part. So if you have a 2K memory, 2K, still looking at that page 35, the solution on top. And 2K means that you need, 2 times 1024, right? which means it's 2048. 2048 can be expressed in hexadecimal. So be friendly to your calculator, and your calculator will serve you well in the exam. Okay, please know how to use your calculator. Don't go in the exam hall and start to find the keys. It's too late.
So what if my computer is there?
Right? Sharpen your knife before you go to what, right? Sharpen your knife first. Okay, or sharpen your pencil if you want your layman term before you go for exam. Don't go inside then start to sharpen. It's too late. Okay? So sharpen your knowledge before you go to exam. Same thing. Anything you must sharpen first. Okay, so page 35. Any question? Do you think you can do that one? Page 35, maybe take a look first. Page 35, the remaining part is just the memory only. You just add the hexadecimal. Okay, so this one, I hope okay. So if I were to quickly sketch this thing, right, on the page 34, okay, I've divided it into 4 segments. So this one is 4K flash, right? 1K. Okay, so we know that this one all in hexadecimal. Okay, this whole chunk here is some of you yawning already. Very tired already, yeah, I know. Okay, so you can do all your segregation. What is P? What is Q? This one refers to here. This point here is 03FF. So the next one will start at 400. No choice, but not complain. There's always a choice. Take out the plug, right? Unplug. You have a choice. Okay, there's always that transition. So your R is what? What's your R? Okay, it's all on this part here. This is your R, right? Okay, I'm going to finish with this one. C and N. Okay, you all understand this, right? This part here is 1000. We are showing you the transition here. And the last one is, what is S? S is, S will be 1 FFF. Okay, pause.